speaker would be Nicolas Frankel.
Hi, everybody.
I'll just quickly introduce Nicolas. He's developer advocate with 15 years of experience in consulting for many different customers in a wide range of contexts, such as telecom, banking, insurance, large retail and public sector, usually working on Java, Java EE, and Spring technologies, but with focused interests like rich internet application, testing, CI/CD, and DevOps, currently working for Hazelcast. Also double as a teacher in universities, in higher education school, and a trainer as a book and also a book author. I would like to welcome Nicolas. Over to you, Nicolas.
Thanks. Hi, everybody. Thanks for having me. Thanks to be here for this talk about zero downtime deployments. Well, I already have been introduced. I work for a company called Hazelcast, and Hazelcast, we provide two products. The first one is an in-memory data grid. So you can think about an in-memory data grid as distributed data structures. So you have your usual data structures, such as map, lists, sets, but then they are distributed all over the network. So they are, you have replication and you have sharding, and everything is available in memory, so it's very fast. And the other one is Hazelcast Jet, and Hazelcast Jet, we do stream processing in memory. So we leverage Hazelcast IMDG to deliver you very, very fast compute. This talk is about zero downtime. So how do we define zero downtime? Well, it's the fact that when, as a user, you use an application, even if there are changes on this application, the user doesn't notice it. And the question is, why should we do zero downtime? Well, the first reason is because of you. Because if you want to work for a company and this company tells you how they do their deployment, and their deployment is done having on the web server a page saying, hey, we will be back in a few minutes, most engineers will frown upon that because it's not hype, it's not cool. You cannot write that on your CV, and in the end, this company won't attract so many good engineers. The second reason is that users, they expect it. Like if you have family members been using Facebook, Gmail, Google, whatever, they never have such a screen saying, hey, we will be back in a few minutes. Those big companies, they practice zero downtime all the time. And so users, they don't understand the concept of upgrading an application. For them, zero downtime is norm. And the third reason is that the business sometimes requires it. I've been working in e-commerce for some time, and if in an e-commerce shop, you bring down the shop to do your upgrade, your customers, they will go to buy somewhere else. So you will bring down your revenue. And for most companies, that is not acceptable. So for all those three reasons, you might consider zero downtime very, very deeply. But zero downtime, we already have it, actually. There is something called blue-green deployments that has been around since ages. And so you have two SEM environments. One is considered green, the other blue for whatever reason. The important stuff is they are exactly the same. And at any point in time, you have a front-end router. It can be a physical one, software one, that send the request from the users to the green environment. And when you decide to do a deployment, you do the deployment on the blue environment. And when it's time to upgrade, then you just need the router to tell, hey, people, now you are on the blue environment. And that looks super easy. Of course, it's not that easy, because what about the data that was written on the green database? Well, it's easy. Then you have a single database. And so you don't have this issue with data, of migrating data. But there are still other issues. For example, there is this routing latency. So when you say, oh, let's direct the users, it might not be instant. So when you decide to do the routing to the other environments, there might be some latency and it might create issues. We didn't talk about users that were still using the green environments. What do you do about them? They still are using the green environment with the old version. And so how do you handle them using now the blue environment? And finally, I mentioned it in passing, database management. Either you need to instantly migrate all your data from the green environment to the blue environment. And if you have millions of rows, it might not be that easy. Or you have compatibility issues, like what happens if your database schema is changing? And Kubernetes comes, and Kubernetes, as everybody knows, solves every problem on Earth. And Kubernetes solved this problem by using the rolling update principle. So basically you have multiple nodes, and then when you decide to do an upgrade, it will roll every upgrade on every node one by one.
Hey, Nicolas, just a moment. Would you be sharing screen?
I forgot to share my screen. No, that's evil. My God. I'm so ashamed. I am so ashamed. Is it better now?
Yes.
I'm really sorry.
You're just talking
really
and
sorry.
then you would roll out your screen or something. Thank you.
Yeah. So just a couple of slides before, blue-green deployments, switching to the blue environment, one single database, and the problems that I mentioned. And now, as I talked about without the slides, but now you have the slides, you have these rolling upgrades of Kubernetes. So you change node by node the version and everything is fine. And it's very easy to do that. I mean, it's just a matter of using the object deployment and then saying rolling updates, you define the max surge and the max unavailable, and it's done. And so when you deploy a new version, that's how it's handled. So this max surge is the number of extra pods. So this is a baseline. We have 3 replicas. And max surge, it's how many extra pods do we allow above that number. And max unavailable is the number of pods that during the rolling upgrade. So in the first case, we accept to use extra resources. So if you're on the cloud, to pay extra stuff. And on the max unavailable, it's the number of pods that we accept that will be done. So we accept that at some point there will be less redundancy. And here is a little diagram that I draw to show you how it works. So here I have max unavailable 1, max surge 1. So basically, if my baseline is 3, that means I might have 4 pods at some point, and then I will get back to 3. So at the beginning, I have version 1.0, and then Kubernetes will spin off a new pod with version 2.0, and then it can remove one of the 1.0 pods, and then so on and so forth until every pod is 2.0. On the other hand, if we cannot pay more, if we don't have enough resources, we can say max unavailable 1 or whatever, and max surge 0. And so the baseline is still free, but then first Kubernetes will remove one of the old pods, v1.0, and then it will create the 2.01 until again, all of them have been replaced. And in the end, we can combine both. And so this is the same. So we can have the baseline of 3, but then we can have a 1 additional and 1 less, so that it gets faster and faster to do the stuff. And of course, here the example is pretty stupid because I'm using absolute numbers, but of course you can use percentage, and then you don't need to do that. Of course, it's not that easy because you might know that apps containers, they don't start instantly. So we need to know the state of the pods and to set it as ready. But the good thing is I will be using Spring Boot under the hood, and I don't know if you know about Spring Boot. I assume that you might have heard about it, but basically it's a platform. It's a framework with a platform. And if you are using Spring Boot, by default, you have an endpoint that is called the health endpoint. And so it's just a matter of wiring Kubernetes and Spring Boot together to say, hey, tell me when you are ready. And ping, Kubernetes will ping this endpoint until it receives a 200 HTTP return code, and then everything is fine. And in general, most talks, they stop there, and we are super happy. We have shown how Kubernetes saves the world. We have shown a few integration with other frameworks, and it's good. But it's an Hello World app, actually, because that's not the case. If you might know about this Dilbert comic, like, yeah, Kubernetes, it will solve all your problems. That's actually not the case, because if you followed my points, I was talking about database before, that blue-green deployment, you have an issue with the database, that either you need to migrate the data or you need to handle the schema change. And here it's the same. I didn't talk about it. So if we put the database in the middle, this all application v1.0, and they point to a database with a schema v1.0. So as soon as you upgrade both the app and the database schema, there is a high chance that the v1.0 doesn't work if you have incompatible schema changes. Okay, then we can say, we must make consecutive app versions schema compatible. And then we have this kind of stuff. So now we will be upgrading. And so 2.0 can still work with the 1.0 database. And so we can handle that gracefully. But of course, since we are all good engineers here, we know that we never roll back. And now, if by random chance we need to roll back, we have the same issue as before. We cannot roll back anymore. And in the real life, we roll back a lot, because even if you test everything in staging, you will have issues in production. And so doing an upgrade and not being able to roll back, it's the end of production. It cannot happen. So we are still stuck. But let's think about it. And we can make it work by breaking down this big change that is into a series of steps that are compatible side by side. That can be done. And to illustrate that, I will talk about a sample use case. So I was very bad at university in designing database schema. And here it's the same. At the beginning, I had one big table. And at some point during the life cycle of my app, because my app now is super successful, I need to break down this single table into two different tables with one primary key and one foreign key relationship. I mean, it's not high engineering, but it's not trivial either. So it's a good way to illustrate what I'm talking about. So that's the beginning. I have this table person, and now I have a couple of lines of rows. And obviously, you can see that there is something that is like bound to an address. And I want to move those address-related schema to their dedicated table. So something like that. So not super high engineering, but still not trivial. So let's think about how we could make this breaking change into a series of compatible changes side by side. So the first is we will create the address table in the first step. And every time we do a change on the person table, so if we add a new row, if we change an existing row, we will trigger, I'm not saying how, but we will trigger the copy of the data from the person table to the address table. And still the application will use the person table in all cases as its source of truth. So this is the first step. If we need to roll back, what will be left is an address table with some data, but the person table will still be used and nothing will have changed. So we can just clean up the address table, nothing will have changed. The second step, we keep the person table, we keep the address table, but now the address table becomes the source of truth. And every time we do a change on the address table, insert, delete, whatever, then we copy that change on the person table. Again, if we roll back, then the person table still has everything that we need. The third step will actually be like stop copying the data, and the fourth step might be completely asynchronous. We just remove the extra columns in the at person table because they are not used anymore. So at every step, we can do a one-step rollback, not two, because that's not the point. One-step rollback, and it's good enough. Now, as I mentioned, I will be using Spring Boot, so I don't assume that you know Java, but just in short, by default, Spring Boot tries to be very, very smart. And if you are using GPA, so Java Persistence API, it will read your entities and it will create the table from the entities. So it tries to be smart. In that case, we don't want that, because that means that if we deploy a new version of the entities, then it will try to update the schema. And we don't want that. We want to be the one to update the schema. So we will delegate it to something called Flyway or Liquibase, but here I'm using Flyway as an example. And Flyway, I don't know if you know it, but if you don't, you should really, really look it because it's version control for your database. I mean, your code is version. Your infrastructure might also be infrastructure as code and is version. But in many, many cases, your database schema is not version. And so if you have an issue, it's sometimes very hard to get back to the state you were in production. And this is a description, so it advertises itself actually as version control for your database. Very, very short description of Flyway. It's based on something called a migration, and migration is just a SQL script. So you are in control of your script. You write down in it whatever you want, and based on the name, each migration will have a version. So you will have version 1.0, 1.1. You decide, because you handle the numbering, the versioning. And Flyway knows how to order those versions. So it knows, for example, 1.0 comes before 1.1 and 1.1 comes before 2.0. At every step, it will create first a dedicated table. And every time it runs a migration, it will write down this migration into the table. If at any point in time, it will try to run all migration, but first check into this table. And if a migration has already been run, then it will skip it. So if you deploy a migration, an app which has X migration, and all those migrations have already been executed, then it will do nothing. And if you have extra, it will just run those extra migration in the order that you decided because of the versioning scheme. There are a couple of ways to run those migrations. The first thing, there is a CLI available. If you are in the Kubernetes world, you probably know about job. You might also know about init container or Spring Boot integration. And in all those scenarios, in all those options, actually, the only right one is a Spring Boot integration. think about it. What I want to do is the first time I deploy the first node in a rolling upgrade, I want the migration to be run. Meanwhile, all other pods that are deployed, because when Flyway does execute the migration, it locks the table. So all those other nodes, they will try to lock the table, but they will be like waiting for that. So the first node that gets deployed, that gets scheduled, it will actually run the migration and continue. So it will afterwards remove the lock. The next pod will try to acquire the lock. It will read the migration table. It will see that all those migrations already been applied, and it will start. And on for all other nodes. So the first nodes that get scheduled will actually do the heavyweight work, and all the other will just check that they are compatible, and everything will be fine. So how do you handle that? Well, with Spring Boot, it's very easy. You just write your migration in a dedicated folder, and when the application starts, the migration gets executed because of the integration. So now I've talked a lot, even without some of the slides, but it's time for a demo. So let's do it. I have created my application. As you can see, it's a Spring Boot application. It's written in and here I say it's Kotlin stuff, and I'm using something for lazy developers. Instead of creating a Docker file, I'm using the Jib plugin. And because I'm using the Jib plugin, every time I do a compilation, it will create a Docker image and send it to my local Docker daemon. And right now, my local Docker daemon is Kubernetes. And well, that's all. I've created also a Docker file, but for my database. I'm not using something fancy at MySQL or otherwise. I'm just using H2. And if I check the H2 console right now, I can check that here I have this stuff running and it is empty. So it has nothing. It's just a brand new server. We can check here that I have get pods. So I have this that stuff running the H2 latest, and latest is the one that I declared. So now is the right time to create our application. This application, as I mentioned, is a Spring Boot application. It has two endpoints, one to get everything from the database and another one to insert a new entity in the database. I should be on the right place. Git checkout 1.0. Yes, I'm at the right place. And now I will deploy the version 1.0 of my application. And this version 1.0, I have an associated migration. This is the initial table, person with all address related stuff. And I will have one insert just to check that there is something. And here I have this model that gets mapped. It's written in Kotlin, but it's not the important stuff. So let's deploy it. I have alias my kubectl to bk because I'm super lazy. And this and it's version 1.0 right now. And so I have integrated it with the actual health endpoint. And now if I check here, if I check here, you can see that there is this Flyway schema history. And we can see, oh no, I hate it. the migration has failed. So now what I will be doing, I will be very, very quick. For whatever reason, I've got an issue and I need to stop everything. Otherwise, all my other demo will be down. So sorry for that. I just need to do that very, very quickly. 0, no, get deployment. It happens sometime, I don't know why. K delete deployment database as an application. Okay. That's the demo syndrome. Sometimes it doesn't work that well. I know that so I try to be simple, but of course, when you are simple, it doesn't work all. Database. Okay, and now I will apply the application.yaml. Because otherwise I will feel very, very awkward. Yes, now it should run. Okay, get pods. And normally if this is my application, and as you can see, I'm an engineer, I'm not a designer. So this is the first version of my application. I can add entities, everything is working. North Pole, good. So on the next version, what I want to do, as I mentioned, is here I'm using the person table. So you can see the one that was written directly by my script, the one I just created. So the next step is to actually create the address table and keep the person table as it is. And every time there is a change in the person table, then I will mirror that change in the address table. So I will deploy the new version. And the new version of the code is the following. So I have this new migration and I create the address table. And on the model, I have created and now mirror this change. You could have a trigger or you could do it in code. And because I'm a developer by trade, actually I'm doing it in code. So I've written something that hacks into the persistence framework. Persistent framework is actually Hibernate, and it reads like that. Every time I do an insert, if the insert is of type person, then I will create an entity as well. Let's check if it works. So normally here, I should have the address person, the address table, and it's empty, of course. Now, I'm already been on the new version because Kubernetes did its rolling upgrade. And here I can create a new entity. And here row has been created. And of course, on the address person, you can see I still have the same data. But now, because the person table is a source of truth, I can do a rollback. Now let's do the apply on the new version. So I will git checkout v2.2. No, not 2.2. And I will k apply f application.yaml. And meanwhile, I will try to prove that it's zero downtime. So I will do a git watch because it might take a bit of time. K get pods watch. So, and at some point, Kubernetes will have terminated it, and the next requests will need to be forwarded to a running pod. It can be a 2.1 pod, it can be a 2.2 pod, and here I am. And as you can see, I never missed a beat. And I can create a new entity again, Andrew Miller, and it still works. And now the good thing is that I still have all the address here because I've done my migration. At this point, because now the address table is a source of truth, actually, I need to migrate all my previous data to this new table. And just for fun, I want now to get back to the previous version of the code. So I will, because let's say that we missed something. So I will git checkout v2.1, and I will deploy this old version just to, and now no migration should take place. So basically now it's, it takes a bit of time. I can still do the git watch. I'm still running on my pod because Kubernetes decided not to kill this one first. So it's completely random here. Now I'm on the 2.1 pod again, and I can still see all my previous data, and I can see all if I need to do something. So I have somebody working, I don't know, Jane Doe, because there is already a Jane Doe. I can still be working with the application even though I did a rollback before, and I still have all my data. So now the next step is, again, to fix the problem and to go on v2.2, v2.3, and everything. But I mean, the takeaway of this book is that zero downtime is possible. I mean, everybody can do it. It's not rocket science. Again, you just need to break down a big non-backward compatible change, a breaking change, into a series of steps of compatible changes side by side. But contrary to popular belief, it's not free, it's not easy. I mean, you need to handle this incompatibility in the database schema. Your applications needs to handle the fact that, hey, whether I'm working in this schema, then I do this, or I'm working with this schema, and I need to do this. So it's not free. And here, I did it with one non-trivial but still easy breaking change on one code base, on a demo code base. Now imagine you need to do that on a lot of different branches because you are using feature branch development. It could be very, very hard because now for every breaking change, you would need to have this breakdown. So you would probably have a lot of different steps that are not compatible with each other. So you need to design it upfront. That means that zero downtime is just not enough. It's not the operator in doing that. So thanks for listening to me. You can read my blog. You can follow me on Twitter. You can, of course, check the company you're working for, Hazelcast, and finally, you can get the sources for yourself and try to redo what I did here by yourself. And now perhaps there are some questions. Or I lost everybody.
Hi, Nicolas. We have, I think you addressed this question, but still, if you can highlight, why would you make your application zero time, and what would be its major impact of implementing the same?
Well, why would you? I explained in the beginning. The first is because of engineers. Engineers want to work on Kubernetes, want to work on microservices, want to work on the latest hype. And so most companies, they need to accommodate that and offer their engineers like a challenging environment. And this is very challenging. The second reason is that actually people expect it. Like, when was the last time that Facebook showed you a screen saying, hey, we will get back in a few minutes, or Google or Gmail or whatever? So most people, your family who are not engineers, they expect it. They don't understand why they should wait. They don't understand the concept of deployment. And the third reason is, in some cases, it means a direct loss of revenue. When your app is down, if you have an e-commerce shop, you're not selling. You are not selling, you are losing money. So it's not great. What was the second part of the question?
Why would you implement it? I mean, what's the major impact of it?
Well, I try to show it. I mean, the major impact needs you need to design upfront. You need to think about it, because it's not free. Like, you need to understand that it will have a definite cost, and to evaluate whether the benefits overweights the costs. That's not to say you should never do zero downtime deployment. That's not to say you should always do zero downtime deployment. That's to say, please be an engineer, and then you evaluate the balance between the cost and the benefits.
Okay, sounds great.
Other questions?
There are no, I don't see any new questions more.
Okay, so thanks a lot for your attention, and I wish you a